But this isn't the full story, because what we've calculated is when the front wheel of the bicycle just intersects the right front bumper of the car at the intersection, there's actually going to be a range of distances d that will lead to a collision. Said another way, if the bicycle starts off close enough to the intersection, some distance which is less than d, then the bicycle might just clear the car. Now you might think we have to work this problem all over again, but that's not so. What we've done is calculated the distance that the bicycle travels in this time t. If the car starts out a little bit closer to the intersection, let's say instead of starting out somewhere over here, the bicycle starts out somewhere over here, then when the car arrives at the intersection, the bicyclist, instead of being right here, is going to be perhaps right over here. So if we want to find out whether or not the bicycle is going to clear the intersection, we just have to figure out how far into the intersection the bicyclist has to be. Well, the bicycle has a length L. So if we say that the bicycle started out at a distance, which was just the distance we previously calculated, VB divided by V sub car times the distance the car started away, and make it a little bit smaller by the length of the bicycle, then what we know is that if the bicycle starts out at this distance, the rear wheel of the bicycle is just going to be at the curb when the car gets to the curb. Well, that's still no good, because the bicyclist is still going to be hit. What we actually need is for the rear wheel of the bicycle to clear the car, to be a distance w away from the curb. So if the bicyclist starts out an additional distance closer to the intersection of minus w, if we subtract off minus w from the distance that we calculated before, then we know that the rear wheel of the bicycle is going to clear the left front bumper of the car. When the car arrives right here, the bicyclist is going to be right there. So for there to be an intersection, the distance d has to be greater than the distance that we just calculated. We're still not finished, because what we've calculated is for the bicycle to intersect with the front bumper of the car, to collide with the front bumper of the car. But the bicycle could collide with anything along the car. What we have to happen is that the car will have cleared the intersection, or at least cleared the curb of the intersection, be all the way into the intersection for the bicycle to be able to squeak by without a collision. In other words, we calculated when the front bumper arrives at the curb. The front bumper was a distance d away. What we need to calculate is when the rear bumper clears the intersection, and how far away the bicycle would have to be so that the bicycle arrives at the intersection when the rear bumper is just clearing the intersection. You might think we'd have to work this problem again, but we don't, because we've already calculated the problem for when the front bumper hits the intersection. Now we just have to calculate for the rear bumper. The rear bumper starts a distance capital D plus capital L away. In other words, the rear bumper starts at some distance, which is this distance over here, and this distance is just D plus L away from the intersection. And we'll know that the car will clear the intersection if we just substitute D plus L for D in this equation over here. Consequently, if the bicycle starts out a distance which is equal to VB, V bicycle, divided by V car, and then times D plus L, then the car will have cleared the intersection by the time the bicycle arrives here. In other words, if the bicycle starts out at a distance that's less than this quantity that we just calculated and greater than this quantity that we just calculated, then the bicycle will have a collision with the car. Finally, we're ready to plug in the numbers. We've got VB divided by VC times D is going to be equal to 5 meters per second divided by 15 meters per second times the distance big D, which is 100 meters, and that's approximately equal to 33.3 meters. Now, using that result, we can write down that 33.3 meters minus little l, which is 1.5 meters, minus w, which is also 1.5 meters, has to be less than d, which has to be less than, well, VB over VL is 1/3. And now we've got D plus L. So D plus L is 100 plus L was 103. So that's 103 meters. And our final answer is that, adding together everything on the left-hand side, that's 30.3 meters has to be less than D, which has to be less than 34.3 meters. If the bicycle starts anywhere in this range, D between 30.3 and 34.3, then there will be a collision at the intersection.